Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, hello everybody. Today we're going to be looking at vertical projectile motion. This is our first lesson on this topic, so I will be taking it a bit slow. I'll be explaining the concept. I'll be, towards the end of this video, going through an example from a past exam paper, and hopefully by the end of it all, it is simple and it all makes sense. Okay, so vertical projectile motion. Let's get started. What is vertical projectile motion? Well, this topic is made up of 3 words, and we're going to break down these 3 words to understand fully what we are dealing with. Okay, so the first word that we see here is vertical. Right, it's the word vertical. What does vertical mean? Well, vertical simply means in the vertical direction, perpendicular to your horizontal direction. So this is your horizontal direction, then this is going to be your vertical direction. It just means 90 degrees from the horizontal. Okay, so 90 degrees from the horizontal is the meaning of vertical. So we will be looking at a direction that is vertical. Okay, so vertical is simply a direction. Now, what is a projectile? A projectile is simply something that is projected. Okay, so what is the meaning of the word projected? To project something is to simply throw something, or it's to apply a force onto something, right? It's to apply a force onto something, giving it momentum, causing it to move, right? Okay, so we understand what vertical is, we understand what projectile is, and what is motion? Well, motion is simply movement. Okay, so vertical projectile motion is the movement of an object or the movement of a body in the vertical direction under the influence of gravity. Okay, under the influence of gravity. Now I'm gonna break that down a little further, or I'm gonna make it make sense as I explain the topic in a bit more detail. Okay, so vertical projectile motion. If I've got a boy here, could be a girl, right? Whoever, I've got somebody here holding a ball, and this person decides to throw the ball upwards in the upwards direction, right? The ball is being thrown upwards in the upwards direction. This ball is what we call the projectile. Okay, so this is the projectile because it is an object that has been thrown, right? And to project is to throw. So this ball in this instance is the object and it has been thrown, so therefore it is the projectile. And the direction that it has been thrown in is the vertical direction. So it's been thrown up, right? It's been thrown perpendicular to the horizontal. It's been thrown at 90 degrees to the horizontal. So this ball is the projectile and it has been thrown upwards at 90 degrees. Okay, and it is moving upwards, hence the motion. It is moving upwards in the vertical direction under the influence of gravity. What do I mean under the influence of gravity? I mean that the only force that is acting on this ball as it is moving upwards is its own weight. And weight, we know that weight from grade 11, we know that weight is equal to gravity times mass of the object, to the gravitational acceleration. So weight is equal to the mass of the object that we're looking at. In this case, it's the ball times the gravitational acceleration. Okay, so to simply summarize that, vertical projectile motion is the movement of a body or an object in the vertical direction under its own weight. Okay, with the only force that it's experiencing being its own weight. Okay, so that is what vertical projectile motion is. Now, as we study vertical projectile motion, there are a couple of things, or a couple of facts that we are going to familiarize ourselves with in order to be able to solve these problems. Okay, so now let's look at, I'm going to redraw the boy again, throwing the ball upwards. If I've got a boy again, or a girl, that's standing here and then throws this ball upwards, what's going to happen to this ball is that this ball is going to travel up. It's going to travel up, and as it's traveling up, it will be slowing down. So it will be thrown up with a specific velocity. Let me write a small v, or let me just write the full word out. It will be thrown up with a certain initial velocity, I. Okay, I for initial. Okay, it'll be thrown up with an initial velocity. You've got a boy standing there, he decides to throw the ball up with an initial velocity, with a certain velocity, with a certain speed, right? As the ball goes up, and up and up, this is the same ball, goes up and goes up, it goes up, it will slow down, right? If you've ever played with any ball and thrown it up, you will realize that as you throw it up, it will slow down, up until it reaches some point there, up until it reaches its highest point. Then after reaching its highest point, it's gonna come back down towards you. If you've ever thrown a ball upwards, right? I'm sure everybody has thrown a ball upwards, and then it'll come back to your hands, and then you will catch it. So it will go up with a certain velocity, the velocity from your hands, the velocity that you applied on the ball with your hands. The ball will go up. Then as it goes up, it will reach its maximum point, right? It will reach its maximum point, its maximum height. Then after reaching its maximum height, it will start going back down slowly. It'll go back down slowly, and as it goes back down, it'll increase its speed. It'll fall faster and faster and faster up until it reaches your hands, and then you catch it again. Okay, so you can simply go outside and check that. As you throw it up, it goes up very quickly, and then it slows down up until it reaches its highest point. After it reaches its highest point, it comes back down slowly and then starts accelerating or increasing in its speed up until it comes back down to where you threw it from, and then you catch it while it's moving very quickly. Okay, so that is basically you projecting an object vertically upwards. Okay, that is simply you throwing an object upwards with a certain speed, and then the object falls back down under its own weight. Okay, it's being pushed back down under its own weight. Okay, so that is there are a couple of things that I want you to note from that. Okay, I'm just going to go to a new page. I'm just explain these things. Okay, I'm going to use the ball still, the ball and the boy. Now, as the ball and the boy are in this position, or let me just draw this properly. Could be a girl, could be a boy, right? Let me draw a girl this time. As this person is here with the ball has a certain velocity I. The ball is thrown upwards. As the ball reaches its maximum point or its maximum height, it slows down, and then it's not moving for a split second, like for a very small amount of time. The ball is not moving. As you throw it upwards, before it changes its direction and comes back downwards, it stops moving for a split second. Just for a very short period of time, it stops moving, right? Because it stopped moving once it's reached its maximum height. Remember, at its maximum height, that's where it stops moving for a very small period of time, for a very small amount of time. Then the final velocity at that point, right? Or let me just call it the velocity, not the final velocity. The velocity at that point is equal to 0. This is before it starts coming back down, right? It went up very quickly. You threw it up, it went up very quickly, and it reached its maximum height. So here, this is maximum height, right? This is maximum height. It reaches its maximum height there. As it reaches its maximum height, the velocity is 0, right? It's 0. Now, this velocity is 0 just before the ball changes its direction and starts falling back down. We all know that if you throw a ball upwards, it won't go upwards forever, right? It will come back down. Why does it come back down? Why does the ball come back down when you've clearly thrown it upwards? Because acceleration is always negative on the ball. Acceleration is always pulling the ball. Acceleration is always pulling the ball back downwards towards you, right? So even though the ball is moving upwards, the acceleration, the gravitational force is pulling it downwards towards the earth, right? So the ball has reached its maximum height. As it's reached its maximum height, it wants to change direction and come back to you. When it wants to come back to you and change its direction, the velocity is 0. Now, when it starts coming back to you, the velocity starts increasing from 0 to a bigger negative number, right? To a bigger negative number. Now, the velocity in the beginning, and the velocity in the end when the ball reaches your hands again is the same velocity. It is that very same velocity that you started off with. Okay, I'm going to repeat that. I'm going to repeat that on a new page just to make sure that it makes sense. I want this to make sense because this principle is going to be, if you understand this principle, then you understand vertical projectile motion for the entire grade 12. You will pass it easily if you just understand these principles that I've just explained. Right, now I'm not gonna draw the person, or actually I'm actually gonna draw the person again to avoid confusion. You've got the person throws the ball upwards. As the ball goes upwards, it has an initial velocity. Where does this initial velocity come from? It is the velocity from your hands, or the velocity from whatever source of force it is that caused the ball to move. Right? The velocity, in this case, we are throwing the ball upwards, so your hands are the source of the force. So that's where the force comes from that caused the ball to move. So, okay, the velocity of the ball, as soon as you throw it upwards, it has an initial velocity, and that velocity is quite big, right? As soon as you throw the ball upwards, it goes up, 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 up until it reaches its maximum height. I'm going to call that H max. It reaches its maximum height. Once it reaches its maximum height, the velocity of the ball at that maximum height is 0. Why is it 0? Because the velocity while it's going up, the velocity is positive because the ball is going up. Now, since the velocity is positive as it's going up, the ball is going to reach a point, is going to reach an instance where it wants to come back down. Now, if the ball wants to come back down, it means that the velocity is going to have to be negative. Now, in order for you to move from positive to negative, in order to move from positive to negative, you must pass by 0 first, right? It is impossible for you to move from positive to negative or from negative to positive without passing by 0 or without passing through 0. That's why you've got a velocity of 0 just before the ball changes direction and comes back down towards you. Now, as it changes its direction, it's going to move from 0. It's going to be negative. The ball is going to have a negative velocity. It's going to have a negative velocity. When it gets back to the point from which it was thrown, the absolute values of the velocity, so this final velocity is going to be the same as the initial velocity, but the signs will be different. Why are the signs different? Because here you threw the ball upwards, right? You threw the ball upwards. As you threw it upwards, it had a positive velocity because it was moving up. Now it went up, it reached its maximum point. As it reached its maximum point, it had a velocity of 0. Now it decided, I'm going to change direction. As it changes direction, it has a negative velocity and it comes back to the point from which it was thrown. And when it gets to the point from which it was thrown, the velocities are the same. The velocity that you started off with is the same as the velocity that you ended up with. The absolute values are the same, but the signs are different because it's coming back down here. So this will have a negative sign and this will have a positive sign. Okay, now why does the ball come back down? I'm gonna try to explain that in a bit more detail. Now, before I do calculations and get into the numbers, I just want to explain this conceptually so that the concept makes sense. Okay, I'm gonna try to explain why does the ball come back down. Right, now if you've got the Earth, there's the Earth, right? This is planet Earth. This is planet Earth. And we know that everything that is within a specific layer, that is within a specific distance from the Earth, right? Everything that is within a specific distance from the Earth has a force that it is experiencing. What force are the things that are within this layer experiencing? And I'm talking about human beings, I'm talking about objects, I'm talking about everything, right? Animals, cars, whatever, everything that is within this layer, this layer of the Earth is experiencing a force. What force is it experiencing? It's experiencing a gravitational force, a gravitational pull from the Earth's center. Now, the Earth's center is pulling everything towards it, right? If you've got a person that's standing there, this person is being pulled towards the center of the Earth. That's why when you jump, you fall back down, right? When you jump, you don't just go up forever. You fall back down. Why do you fall back down? Because gravity is pulling on you. There's the gravitational pull of the Earth that is pulling on you. Now, the same concept applies with vertical projectile motions, right? Whenever you've got a person here and you throw a ball upwards, this ball goes up. It goes up because you applied an upward force onto it, but then it'll eventually reach a point where it wants to come back down, because even though it's going up, right? Even though it's going up, it is always experiencing a gravitational pull from the earth. Now the earth's center is somewhere down there, right? It's experiencing a gravitational pull from the earth's center. That's why this ball will go up until it doesn't go up anymore, up until it changes direction and comes back down, because the earth is pulling it towards its center. Everything will fall. That's why we fall. That's why things fall to begin with, right? That's why if you push something off a table, it falls down. It doesn't go up. It doesn't float. It falls. Why? Because the earth's core is pulling onto that thing. Okay, so that is the basis of vertical projectile motion. Whenever you've got an object, it doesn't matter if it's a ball, it doesn't matter if it's a bullet, it doesn't matter what it is. If anything is thrown up, it will fall back down, right? It will fall back down. And another thing for you to remember is that if you've got the earth, right? The earth has a gravitational pull. I'm gonna call it G. It has a gravitational pull, right? And then you've got your layers here. You've got your atmospheric layer. You've got your stratosphere. You've got all these layers here, right? Now, if you ignore the effects of air friction, we have what we call friction in air, right? If anything that goes through air, it experiences some amount of friction. But if you ignore the effects of friction, in air, then it doesn't matter if you've got like a small stone or a big watermelon. If you throw these two things from the same elevation, right? Let's say you've got like some tower here. You're standing on a tower, and then you've got a person that's standing there, and then this person decides to throw a watermelon from that tower, and you've got another person here from the exact same height. So these two heights are exactly the same, right? This person throws a watermelon from here. This person throws a pebble. These two objects are both experiencing the same force. And what force is that? That is the same force from the center of the earth. That is the gravitational force, the gravitational pull from the earth's center. So both these things are experiencing the same force. Now, since these two objects, this watermelon, this big watermelon, and this very small pebble, are experiencing the very same force, they will reach, if they are released at the exact same time from the exact same height, and we ignore the effects of air friction or air resistance, we pretend as if the air is not there, or the air has no effect, right? These two objects will reach the ground at the exact same time. They will reach the ground at the exact same time. Why? Because they are experiencing the same exact force or the same exact pull from the earth's center. It doesn't matter how much they weigh. If they are experiencing the same force from the earth's center and there is no air resistance or there's no air friction, then they will reach the earth's surface, or they'll reach the ground at the exact same time. Doesn't matter if this is that big or if this is that small. Okay, so those are some of the concepts and some of the principles that I want you to understand. Okay, so far what I've explained is, I'm just going to summarize quickly. What I've explained is that, one, right? If you've got a person with a ball, can be a ball, it can be anything, right? It can be anything that you throw up, right? Or that is moving vertically, either upwards or downwards. If you've got a ball and you apply a force, an initial force onto it, you apply the force and you remove the force, so that the only force remaining is the gravitational force. This thing, if you throw it up by applying a force upwards, it'll have an initial velocity. That's number one. It'll have an initial velocity, and that initial velocity will be positive if you decide to make upwards the positive direction. Number two, when that, okay, I'm going to draw the person down here. When that ball reaches its maximum height, then the velocity at that maximum height is 0. And then your ball is preparing to change direction, to move in the opposite direction from where it came, which is downwards, right? The velocity is 0 at its maximum height. Okay,
maximum height, this is supposed to be an x. At the maximum height, the velocity is 0. Now, when it's at its maximum height, let's do that. When it's at its maximum height, it will want to change direction, right? It will want to change this. It's still at its maximum height. Now it is beginning to change direction. As soon as it changes its direction, that's the maximum height there, right? That's the max height, max h. As soon as it changes its direction, the sign of the velocity also changes. Now the sign of the velocity is negative, and it accelerates downwards at an acceleration of g. Now what is g? G is equal to minus, it's minus because it's always moving downwards towards the earth, right? Minus 9,8 meters per second squared. This will be in your formula sheet or in your data sheet, this value, so you don't need to memorize it, but it's fairly easy to remember, right? The ball will start moving downwards and it will continue moving downwards at that acceleration. Now just to go back up there, just because point number one there, just because the ball is moving upwards does not mean that the acceleration is positive. Please, the acceleration is still g here. Now, if there's anything important, one of the most important things that I need you to remember is that the acceleration is always minus 9,8 meters per second squared. Always minus 9,8 meters per second squared. Always, regardless of whether the ball is moving upwards or downwards. Let me repeat myself. Regardless of whether the ball is moving upwards or downwards, the acceleration is minus 9.8 meters per second squared. It is the same gravitational pull that the ball is experiencing, whether the ball is moving upwards or downwards. And please pay attention. I'm only saying ball here. It could be a ball, it could be a bullet, like I said, it could be a pillow, it could be a table, it could be anything that has been thrown upwards and is moving back down. Anything is experiencing the gravitational acceleration of minus 9.8 meters per second. The thing that changes in its sign is the velocity, right? When the ball is moving upwards, the velocity is positive. When the ball is moving downwards, the velocity is negative. When does the ball move downwards? After it reaches its maximum height. After it reaches its maximum height. Now, at its maximum height, the velocity is 0. Okay, now, those are the important steps. I'm just going to add the last one. Let me just recap quickly. First step, you throw the ball upwards. It has a maximum initial velocity. When you throw it upwards, from the point that it was thrown, it has its maximum velocity, right? As it reaches its maximum height, the velocity becomes 0. Why does the velocity become 0? Because the ball is being pulled downwards and it wants to change its direction. But before it can change its direction, it must slow down and it must be 0 first. Because you can't move from a positive to a negative without passing through 0. Right? 0 is the transition between positive and negative. That's why we've got a velocity of 0. Number 3, as the ball starts moving downwards, now it has a negative velocity, but the gravitational acceleration is and has always been negative, right? It has always been negative and it will always be negative whether the projectile is moving upwards or downwards. Okay, and then number four, person is standing here. As the ball gets back to the point from which it was thrown, it has a maximum negative velocity, which is the same, the absolute value. Okay, this means absolute value, right? So the absolute value of the velocity is the same as the initial velocity with which the ball was thrown. If I threw the ball upwards at a velocity of 5 meters per second, it's gonna come back to my hands at a velocity of 5 meters per second, just with a negative sign, right? Just with a negative sign. So just to repeat myself again, I know I'm repeating myself a lot. If this ball has been thrown up with a velocity of 5 meters per second, by the time it gets back down to the same position, it will have a velocity of minus 5 meters per second, Okay, so that's how a vertical projectile motion travels. It travels, the ball travels vertically under the influence of gravity. Only, nothing else. No air friction, no net external applied force, nothing else. Just under the influence of gravity. Okay, so that's what happens. That's basically I think I found it necessary to spend all this time just trying to explain the concept. Okay, so let's just do another example. If you've got a person standing on a building, right, standing on a building, and this person shoots a gun up, right, person shoots a gun up. That's a big gun standing here. The person shoots a gun upwards, right? And then the bullet goes from the gun. This is how the bullet will travel, right? Bullet will travel like that. Bullet will travel like that. Bullet will travel like that. This is how the bullet will travel. Notice how the bullet is traveling. We are looking, remember what I said when I started this video, I said we're looking at vertical projectile motion. Vertical being the keyword. Vertical projectile motion. Now, if you're looking at this thing here, you will agree with me that it is moving both in the horizontal and in the vertical direction, because it's moving to the right as it's moving upwards. So it's moving horizontally and it's moving vertically. We don't care about the horizontal direction in this topic, right? We don't care about the horizontal component, we care about the vertical. So how is the bullet traveling? This is the starting point, right? Then it does that. Vertically, it does that. It does that. There's the bullet. There's the bullet. There's the bullet. Right. At that point, the bullet has an initial velocity. In the vertical direction, it has an initial velocity, right? At that point, that is the highest point. And what do we know about the highest point? At the highest point, your velocity is 0. And here you can see that it's moving upwards, right? It's moving upwards. Even though it's slowing down, it's moving upwards, still moving upwards up until it reaches its highest point. Then it starts moving downwards. As it's moving downwards, it's increasing its velocity in the vertical direction. When it's back at that point, that's the same point from which it was shot up. So it has a final velocity, and these two velocities, the absolute value, the magnitude of these two velocities is the same. It's exactly the same value. So if this was 100 meters per second upwards, then this is going to be 100 meters per second downwards. Okay, downwards. So that is vertical projectile motion. You remember, vertical, we're looking at the vertical direction. Even though this thing is traveling in a horizontal direction and a vertical direction, and you'll see in the calculations that we'll do later on a separate video, we will do examples where the thing is actually traveling in the horizontal and the vertical direction, but we're only looking at vertical projectile motion. So that's what we're going to be looking at. Okay, so that's basically what we're looking at. Now, for this topic, we're going to do one example in this video, but for this topic, we have what we call equations of motion, right? Equations of motion. Now, you don't have to memorize these equations. But you must understand them at least, right? So I'm gonna spend a bit of time explaining them before I actually get to the example. Now, the equations of motion were the person that came up with the equations of motion was Sir Isaac Newton, if I'm not mistaken, and they are usually given in your formula sheet, right? In your formula sheet, you've got 4 equations, and these are the equations that you're basically gonna be using in this topic, depending on the information that you've been given. Now, the equations of motion consist of several parameters. Now, you've got what we call VI. I'm going to go to the equations of motion just now, but I just want to explain the parameters before I do that. So you've got VI, right? Now, VI is the initial velocity. VI is the initial velocity. What is initial velocity? What does initial mean? Initial means the first, right? The first, right? So initial velocity, if you've got a person, I'm going to keep using this example, person throwing this ball upwards, Vi is the initial velocity. It's the velocity at which the object was projected upwards. It's the first velocity, right? It's the velocity that you started off with. You're going to have a velocity that you end up with. You're going to have a velocity that you start off with. Initial velocity is the velocity that you start off with. So just in the instant that the ball is leaving the person's hands, or just in the instant that a bullet is leaving the barrel of a gun, right? Just in that instant, the very first instant, that's where you have your initial velocity. Okay, now that is one parameter of your equations of motion. You've got initial velocity, then you've got what we call a final velocity, right? You've got a final velocity, The final velocity is the velocity that you end up with over the period of time that you are looking at your projectile. The last velocity that you end up with over the period of time that you're looking at your projectile. So if I have a person standing here, throws the ball upwards with the initial velocity, and the ball goes up to some point V, then if you are only looking at this time frame from this point to that point, then the final velocity is at that point. So the final velocity is the velocity of the ball at the last position where you are studying the ball. Now, if I tell you that this ball goes all the way back down here, then this doesn't become the final velocity anymore. This becomes the final velocity, right? So the final velocity is the velocity of the ball over the time frame at which you're looking at the ball, that the ball has in the last instance. Okay, at the final moment of its travel, or of its motion, right? So the velocity at the final moment of its motion, of the projectile's motion, is the final velocity. Okay, so one thing to mention about the initial velocity and the final velocity, it is preferred that when the ball travels upwards, the sign of the velocity is positive, and when the ball travels downwards, the sign of the velocity is negative. It is preferable. There's nothing stopping you from doing it the other way around, where you make upwards negative and downwards positive, but you can do it that way. There's nothing wrong with that, but I prefer to choose up as positive and down as negative, and you've got to be consistent with that in all your calculations. Okay, so this is your final velocity here. The final velocity is the same thing, same principle, right? I'm talking about velocity in general. Upwards, if the ball is moving upwards, or if the projectile is moving upwards, your sign has to be positive. If the projectile is moving downwards, your sign has to be negative, or it could be the other way around if you choose it to be the case, as long as you are consistent. Okay, as long as you're consistent with your sign convention. The next parameter that I want us to look at is delta y. Okay, some people call it delta h, delta h. Or some people actually call it h, or some people call it y. Okay, this is all the same thing, delta y or delta h or y. You can call it whatever you want to call it out of these four, right? This is the displacement, right? This is the displacement, and like velocity, displacement is a vector. Now remember what a vector is. A vector is a parameter, is a quantity that has a direction and magnitude. In other words, it has a sign, a positive or a negative sign, and it has a number attached to the sign. Okay, so this one here is your displacement. Now these are very important for vertical projectile motion, and I'm taking a bit of time to explain these things before I actually do calculations, because it's very important to understand these things. Now, what is displacement? Displacement is simply the position from the point of reference at which from which the projectile has been thrown, right? From which the projectile has been projected. So if I've got a person here, and they project, or they throw the ball upwards, from where did they throw the ball from? They threw the ball from here, right? So you will start measuring the position of the ball from the point at which it was thrown. Since it was thrown from here, you start measuring the distance from here, right? Whether this is 1 meter or 2 meters or 3 meters or whatever, you start measuring the projectile from the point where it was thrown. We call that the frame of reference, right? The position from which the projectile was projected. We call it the frame of reference, FOR. Okay, FOR for frame of reference. Okay, so now if the ball is here and this distance here is 2 meters, then the ball is plus 2 meters from the point at which it was thrown. Why do I have a plus? Because displacement is a vector, so it needs a sign, and I prefer to use up as positive. If up is positive and it is 2 meters away in the upwards direction from the point at which it was thrown, then it is plus 2 meters away from the point of reference. That is your displacement is simply a measure of position, right? Now, if say you have this, let's say you've got this person standing on a platform, right? And they throw the ball upwards and the ball goes up and it goes back down there, right? Now you will agree with me that from where was the ball thrown? The ball was thrown from here, but it went up and it went all the way down here. Now it is underneath. It is underneath the point from which it was thrown. It was thrown from here, but it ended up here. It is underneath. Now, if this is 2 meters, right? The distance from this point to that point is 2 meters. Then this is minus 2 meters. Why is it minus 2 meters? What the minus is telling us is that the ball was thrown from here, but then it is 2 meters away from the point at which it was thrown. 2 meters in which direction? Upwards or downwards? Well, because I'm saying minus, then it is downwards from the point at which it was thrown. Downwards from the point at which it was thrown. Okay, so that is what the negative means. Displacement is simply a vector, just like your velocity. Upwards is positive, downwards is negative. You've got to be consistent in whatever sign convention you pick. So if upwards is positive, make sure that upwards is positive for everything. Your velocity is your displacement. You can't have upwards being positive for velocity and negative for displacement, right? It's just going to complicate life. You're probably going to get the wrong answer if you do that. So yeah, so that's the next parameter. That's your displacement. Displacement is simply a measure of the position of the projectile from the point at which it was launched or from the point at which it was projected. Okay, so that is what displacement is. What is the next parameter? The next parameter is time. Delta t. Okay, delta t, that's simply change in time. Now, the time from the moment at which the projectile was launched to the moment at which you stop looking at the projectile, it is traveling over a certain amount of time. It is spending an amount of time in motion, right? In motion under the influence of gravity. That time is the time that we are referring to here. So if you've got a person, they throw the ball upwards and this ball goes up and it comes back down. It took a certain time from this ball to move from this position to that position. It took a certain amount of time. Now, time is not a vector quantity. Time is a scalar quantity, meaning that it does not have direction. Time is always counting upwards, so you can never have negative time. So it doesn't have a sign. Time does not have a sign because it's a scalar quantity, therefore it has only a magnitude. Okay, so what time are we looking at? The time under which your projectile is in motion under the influence of gravity, right? Okay, so and then the last parameter which I've mentioned already that I want us to look at is g, or gravitational acceleration. Your gravitational acceleration is minus 9.8 meters per second squared. That is your final parameter. This parameter is always negative, which I choose to make it negative, right? Like I said, I'm choosing downwards to be negative. So my gravitational acceleration is always downwards. It's always towards the center of the earth, which I consider my downwards direction, right? So this is always, always, always in each and every single one of your calculations. Please, I highly recommend that you keep to the sign convention where up is positive and down is negative. So your gravity is always going to be negative, minus 9.8 meters per second squared. Okay, so that is your final parameter. Now I mentioned a couple of parameters. Now I'm going to go back to the equations, the official equations that were derived by Sir Isaac Newton. But just to recap, the parameters that I looked at were VI, which is your initial velocity. We looked at your VF, which is your final velocity. We looked at your delta Y, which is your displacement. Now all of these three are vectors, right? All of these three are vectors, meaning they have a magnitude. They have a magnitude and they have a direction. Whenever you are doing calculations involving these, make sure that you specify the direction. It's very important. Direction is specified using signs. Okay, we looked at these three and we looked at the other two, which is your time, which is your scalar quantity. It's your scalar quantity, right? So this one does not have a sign. You always use it. You always use a positive, but you don't have to write down the positive. It's always positive, right? You can't have a negative time. And you've got your gravitational acceleration, which is always negative. Okay, this is always positive. This is always negative. Okay, and then these three can either be positive or negative. Okay, so these are the very 5 important parameters in vertical projectile motion, and these are the parameters that you're gonna have to familiarize yourself with it and understand really, really well in order to be able to solve problems that have to do with vertical projectile motion. Now let's just go to the equations quickly. Here are the equations. These will be in your formula sheets, right? This first table that you see here, these are your equations. Let's see if I can edit. Okay, so so this table here, these are equations. Now if you look at these equations, you use these equations depending on the information that you've been given, right? If you look at this first one here, you've got VF, which we now know is our final velocity. You've got VI, which we now know is our initial velocity. You've got A. A, by the way, I called it G, right? A is just your gravitational acceleration. A is G. Okay, A is G in this case for vertical projectile motion. A is G, and then we've got our delta T. Now you understand all these parameters, and they're very simple. You understand what they are. It's just a matter of identifying them in the question. We will do a couple of questions. Identify them from the question, and then plug them in and then solve, right? Here you've got VF. Even though there's a squared there, don't let the squared intimidate you. It's just telling you that you've got your final velocity being squared, right? You've got your VI. There's nothing in this table that you now don't know. A is your gravitational acceleration. Delta X is the same as what I call delta Y, right? Because you're looking at vertical in the vertical direction, so I'm going to use Y, vertical projectile motion. So delta X is delta Y. Don't let that scare you. Same things. It's just different equations, but the same parameters throughout. You see that? Here's delta Y. That's why they're saying O delta Y. Okay, and then you've got delta. It could be delta Y here. Delta X is the same. If you're looking in the horizontal direction, which we are not looking at in this topic, then you have delta X. But here we're looking at delta Y, vertical, right? So that's why you've got delta Y, and then you've got your VI, which is your initial velocity. You've got your delta T, which is always positive, which is your time. Delta T is your time. You've got different variations of the same equations. These equations they all do the same thing. They're just written differently for different purposes, but they all do the same thing. They'll give you the same values depending on what you're given, right? We will do a couple of examples to illustrate the use of these equations, but I think it's a good idea to not actually do any calculations in this video. to dedicate this video to just illustrating concepts, because it's very important for you to understand the concepts. Okay, so those are the equations. In the next video, I will do maybe a couple of examples. So I'll do one example, an exam question that is a bit long, to illustrate all of the concepts. But yeah, so there's really nothing complicated about this. Okay, so I want you to understand that vertical projectile motion is just you've got an object, or you've got a body that has been launched in the vertical direction, in the upwards direction, with a certain velocity. As long as it's moving up, it has a positive velocity, but it's always accelerating downwards with g, your gravitational acceleration. It reaches its highest point. At its highest point, it wants to change direction, so the velocity is 0. And then once it changes its direction, the velocity is negative, but the acceleration is still negative, as it has always been, even when the ball was moving upwards, and until it gets back to the point at which it has been launched, or even further beyond. And then, yeah, it's a projectile motion. Okay, so I think I'm going to stop here for this video. I think I'll start explaining or doing calculations and examples in the next video. Okay. Till next time.